report down.
The hydride shifts I get. So hydride shifts are on secondary and tertiary.
If you have a tertiary, if you already have a tertiary, okay. If you have a,
when is the methyl shift the tertiary then? Quaternary. Okay.
Yeah, if you have a secondary carbocation and you're next to a tertiary, then there will be a shift, and then you get this guy.
And if that one there was quaternary, then it would have shifted
A methyl
group.
Exactly. Now,
So it's tertiary quaternary.
then the methyl would shift, and then you'd have this guy. And the positive charge is always going to end up on the one that the thing shifted from. Methyl shifted from this carbon, so your positive charge is here. This example, it's symmetrical, but if it wasn't, then it would be important which one you showed it on. Just also remember, if you already have a tertiary carbocation, sometimes people say, oh, this is tertiary. Oh, quaternary is right next to it. Quaternary is bigger than tertiary, so there's going to be some short shift. Would that happen? Why not? Because this shifted over, we just have a tertiary carbocation. So it went from tertiary to a tertiary, so there's no point in shifting anything. So once you're on tertiary, that's as stable of a carbocation as you can have. You're never going to have a quaternary carbocation because carbon has 4 bonds. It's not.
So you're saying you're starting with a secondary, and then if you have the tertiary connected, then it's a hydride. If it's quaternary, you have the methyl.
Yeah, but if you're already on a tertiary,
You're not
going to shift because you can't shift to a quaternary. You can't increase a bit. Some people get that mixed up and say, oh, quaternary is next to it. Something's going to shift.
So shifts only occur on secondary carbocations.
Yeah.
Not even like primary.
Because you won't have a primary carbocation. Though, hold that thought for a second actually, but and if you have on a secondary and you have a tertiary that far away, you're not going to shift twice to get there. Do you remember that homework problem where you go from like a structure and then you form a ring structure?
Yeah.
Now he has to tell you what the product is, so you can have something like that happen, but you're not going to predict that.
Right.
Okay.
Because we never would have anyway.
And then again, if you're next to a tertiary and a quaternary, which one's going to happen?
Tertiary. Right.
So
That's
a hydride shift, right?
Yeah.
Hydride shift before methyl shift.
Beats the
Why?
methyl.
Because hydrogen
It's
has
easier to move. Right?
2 electrons. A methyl has a carbon and 3 hydrogens. I mean, that right there is like 6, 7, 8, 9, 10, like 12 electrons to move.
Okay, so just because it happens faster, not
Exactly.
anything else.
Now, the whole idea that you won't have a primary carbocation, absolutely true. Memorize that, learn that, know that. So you'd always think S and 2, so there won't be a shift. Like even if I had this guy, I mean this is a primary alcohol, it's next to a tertiary. If I added HBr to it, the bromine's going to add here because it's an SN2 reaction. There's no shift. But if on your quiz he gives you something like this, and I saw this last year, someone brought this up to me. If he shows you this and he asks you what mechanism is this, what would you say? You went from a primary alcohol and then you notice there was a shift.
So wouldn't it have to be E1 because there was a shift? Or SN1?
SN1. Yep.
Have to be one of the ones.
A lot of people miss this because a lot of people saw primary alcohol, so they thought it's an SN2. Some people missed it because they saw primary alcohol, but they noticed there was a shift, so they put SN2 as shift. You can't have a shift on SN2 because there won't be a carbocation. So yeah, the correct answer would be SN1 with a shift. Now, he has to tell you this.
Right.
If he didn't give you the product, again, you're going to predict SN2.
No shit.
You wouldn't ever write that as given as a minor product. Just in case it's on your quiz.